Welcome back. We are still continuing with pulleys, and I'm Simon taking you through these pulleys. What are we expected to do? We are going to define pulleys. We are going to identify the types of pulleys and the characteristics of each one of the types of pulleys, and then we shall find the difference between the pulleys, and then we shall do some calculations on pulleys. We are beginning with the definition. A pulley is a freely rotating wheel with a groove on its rim. Or a pulley is a freely rotating wheel with a grooved rim. By grooved, we are meaning that there's a depression on the rim. That depression helps to prevent the rope or string or chain from sliding off. So looking at this diagram here, this is the freely rotating wheel with a groove in that rim. It is like the rim of your bicycle has got that groove, it has got that depression so that the tire and the tube can stick there without sliding off. So this freely rotating wheel is fixed in a frame called a block, and it spins from that point. That point where it spins from can be called a pivot. So this is the depression there, that is the groove, and that is the rope there. Types of pulleys. The types of pulleys we are interested in are single fixed pulley, single movable pulley, and then we have the third one called block and tackle. But under block and tackle pulley system, we are interested in what we are calling the fixed movable pulley. We shall define each one of them. Single fixed pulley, we are starting with that one here, the single fixed pulley. It's called single because we only have one. It's called fixed because it is fixed at that point. It rotates from that point, but it is fixed there. And in that place where it's fixed, that's where it rotates from. It does not move with the load. So that is called a single fixed pulley. This is the load. That rope goes through. Of course, it goes through the rim, and then you're pulling towards this side. As the load moves up, you're pulling it down. So let's look at the characteristics. The first one is that there is a change in the direction of force. How come? The load is moving up and the effort is moving down, and it is more convenient to pull from down, pulling downwards as the load is moving up. So there is a change in the direction of force. That is an advantage, which makes it convenient to use. Then two, the effort applied is equal to the load. The effort you are using to pull is equal to the load. If the load is 100 kilograms, then you must be using 100 kilogram force to pull the 100 kilograms. Therefore, as a disadvantage is that it does not reduce on the effort applied, because load is equal to effort, or effort is equal to load. Now, which takes us to the next point. If the load is equal to the effort, then the mechanical advantage is 1. Because we said mechanical advantage is equal to load over effort. So 100 kilograms divided by the 100 kilograms this side, we shall get 1. The mechanical advantage is 1. And then the velocity ratio is also 1. We defined velocity ratio in earlier videos. Velocity ratio is the ratio of the distance moved by the effort to the distance moved by the load. So when the load moves 5 kilograms, the effort will also have moved 5 kilograms. Velocity ratio is equal to effort distance over load distance. Those are the characteristics of the single fixed pulley. We cannot access this pulley. We cannot go to factories now. We cannot go to building construction sites and so on for now, because we are in a corona break. We are in a quarantine. Then we move to the single movable pulley. It's called single movable. It's single because it's only one. It's one. Then it's called movable because it keeps moving. When you are pulling this side, the load goes with the pulley itself. So it's movable. The load keeps moving up and down. Yet with the first one looked at, the pulley was fixed in one position. The arrows are very important here. The arrows are very, very important. Now, this pulley has two supporting forces. Two sections of the rope are supporting it. So let's look at the characteristics. There is no change in the direction of force. There is no change in the direction of force. The load is moving up, you're also pulling upwards. The arrows are very important because one day they can tell you to complete the diagram using the arrows. There is no change in the direction of force, which makes it inconvenient to use. It's not very convenient to use this one. Then, the second one is the effort you put in is a half of the load. The effort you put in is a half of the load, which implies that it reduces on the effort applied. It reduces on the effort you are putting in. Now, let's say the load is 100 kilograms. That means the effort you'll be using to pull will be a half of the load, which means if we have 100 kilograms here, then you'll be using a force of, like, let's say 50 kilogram force, a half of this, which means it reduces on the effort applied. How come? How does that come about? Let's say we have 100 here. Just know that the 50 is shared here, and now you're also using the 50 to share. So normally they ask us, why is the effort a half of the load on this? Because it has got two supporting forces. This one takes the 50, this one takes the 50, assuming that this is 100. Then, which gives us a mechanical advantage of 2. The mechanical advantage is 2. Mechanical advantage is equal to load over effort. So if we are putting in, if we have 100 kilograms here and we are putting in 50 kilogram force, divide 100 by 50, which is 2. So the mechanical advantage will be 2. The velocity ratio will also be 2. Velocity ratio, the ratio of the distance moved by the effort to the distance moved by the load, will be 2. Meaning if the load moves 5, if this one moves 5 kilograms, this one will have moved 10. If this one moves 5 meters, this one will have moved 10 meters, which gives us a velocity ratio of 2. Something that is very important about this, why does it reduce on the effort applied? Because it has got two supporting forces. Why does it have a mechanical advantage of 2? It has a mechanical advantage of 2 because it has got two supporting forces. And the effort is a half of its load. So this table now here is showing us the difference between the two pulleys. Here in the single fixed pulley we have a change in the direction of force, while in the single movable pulley there is no change in the direction of force. With this one, the first one, single fixed pulley, effort is equal to load, or load is equal to effort. Yet with this one here, effort is a half of the load, or the load is twice the effort. The load is twice the effort. Load is equal to 2E, or effort is a half L. This one, single fixed pulley, has got a mechanical advantage of 1, while this one has a mechanical advantage of 2. Single fixed pulley has a velocity ratio of 1, while this one has a velocity ratio of 2. The next part, we are going to work out some numbers on the pulleys. We're going to work out two numbers here on these pulleys. Simon raised a load of 400 kilograms on a single fixed pulley through 7 meters. 400 kilograms through 7 meters, as shown below. We have 400 meters through. We have 400 kilograms through 7 meters. Work out the force needed to raise the load. Work out the force needed to raise the load. So they want us to identify how much effort do you have to put in to raise this. And we have said effort is equal to load. And we know the load. Effort is equal to 400 what? Therefore, effort is equal to 400 kilograms. But they have told us force. Therefore, we have to convert this to 100. I mean, we have to convert this to newtons, which is times 10, which will give us 4,000 newtons. That is the force needed to raise this. If they just tell us how much effort do you need to put in, load is equal to effort, effort will be 400 kilogram force. But since they said they want it in newtons, we had to multiply by 10. Then next, work out the work done. Calculate the work done by Simon. we have always said work is equal to force times distance, which is equal to 4,000 newtons times 7 meters, which is equal to 28,000 Newton meters. 1 Newton meter equals 1 joule. Therefore, 28,000 Newton meters is equal to 28,000 joules. That's the work that is done. Calculate the mechanical advantage. MA, mechanical advantage, is equal to load over effort, which is equal to, now we said we have 400 kilograms, 400 newtons. We have 4,000 newtons. We have 4,000 newtons, and then that was the load, and then the effort. Load is equal to effort, still 4,000 newtons. Divide that, we shall get 1. And like we said, the mechanical advantage of a single fixed pulley is 1. Using an arrow, show the direction of the effort. If this load is moving up, where is the effort moving? The effort will be moving that side. And when you draw that arrow there, you have to indicate done, so that in case the examiner was missing, to mark your number, when they see done, they will first go back and cross-check to see whether they have given a tick. Then next, Giimpse raised a load of 400 kilograms. Now, this is a single fixed pulley, while this is a single movable pulley. Same questions, same load, same distance through. But let's see whether the work done is the same. Giimpse raised a load of 400 kilograms on a pulley through a distance of 7 meters as shown below. Name the pulley system in the diagram. Name the pulley system. According to what we have gone through, this pulley system is called a single movable pulley. Then work out the force needed to raise. So we are looking for the effort. Then when we get the effort, we shall multiply it by 10 to get the force. On this one, they told us that earlier on we saw that effort is a half of the load. A half of the load, which means a half times L, which is a half times 400 kg times 10. Working this out, we shall get 200, which is 200 kilograms times 10, which is 2,000 newtons. That is the force. If they just asked mere effort, we would say a half of that, which means we shall get a half of this, which is 200. But now they want it in newtons, so we have to multiply by 10. Then calculate the work done by Giimpse. So look at the force that Giimpse used and look at the force that Simon used. Simon used 4,000 newtons, Giimpse used 2,000 newtons. That means this one reduces on the effort applied or reduces on the force that we are using because it has got two supporting forces. Calculate the work done by Giimpse. Work is equal to force times distance, which is equal to, we already have the force, which is 2,000 newtons, times the distance, which is 7 meters. This is 14,000 Newton meters. 1 Newton meter is equal to 1 joule. 14,000 Newton meters is equal to 14,000 joules. That's the work done. The work done here, we had 28,000. Here we have 14,000, which is a half of this. Work out the mechanical advantage of the pulley in the diagram. Let's work out the mechanical advantage. Mechanical advantage is load over effort. The effort that was put in was 200 kg. So MA is equal to the load, which is 400 kg, divided by this one, 200 kg. 200 kg. That disappears, that goes, and we shall remain with 2. So mechanical advantage is 2. There are no units on mechanical advantage. Then complete this diagram using arrows to show the direction of force. We need to know which arrow is facing up, which one is facing down. Are they both facing up? Are they both facing down? We said this pulley has got 2 supporting forces. Therefore, both arrows are pulling upwards. Upwards. That one is facing up, and this one is facing up. So they are pulling towards up. This one is also pulling up, and then our load will also move up. So that is it. Then you come and indicate done, so that they don't skip ticking your answer. Thank you for being good listeners. We have gone through a lot. We have defined the pulleys. We have seen the types of pulleys. Maybe I would also want to talk about the block and tackle pulley system. We are interested in a pulley called the fixed movable pulley, where we have one movable pulley and one fixed pulley combined together, giving us a fixed movable pulley. We shall discuss all those. We shall do more numbers when we get back at school after the COVID break. Thank you for watching.